Okay, let's see some practical data processing. In this example, we will follow a very simple tutorial to uh, try to classify images of handwritten digits. So first step is to get the data. Handwritten digit set called MINST is one of the standard image dataset provided by a submodule of Torch called Torch Vision. It's very convenient to use. Import Torch Vision. Okay, let's run it. Now we have the Torch Vision, and let's construct object that manage a particular data set. Let us call it train set. It is Torch Vision. Look, in the environment, which is in the notebook, if you type the first few letters and hit the tab key, the notebook will give you some hints about useful completion of the name or the name of the variable or the library. To get this data set, we need, because we do not have the data right now, and we want to download the data and from the standard repository, we need to specify which directory to download the data. I put it here. Note the double dot means the folder which is the parent folder of the current one. This is our directory, working directory I mentioned in when we setting up this environment. If we open this folder, have a look, we have this kind of structure, and now we are working here. So I would like to create a folder here named data and put all the data in this particular folder. I would recommend you do the same. Note, you do not need to actively create the data folder. Only by specifying where you are intended to save the data, Touch Vision would automatically create the data folder if it doesn't exist. And more than that, if the folder does exist, Touch Vision will use that to manage the data, and if it finds out the data has already been there and processed, it only creates a dataset object pointing to the piece of data without doing any time-consuming operations. Okay, and the need to specify that is for training, and we also need to tell the parameter download is true, means if the data isn't there, try to download it from the internet. What would happen? Sure, it starts the data downloading. While we're waiting, let's prepare for the next step. Look, that is very easy to use. While waiting that working in the background, we do a training data loader. Oh, that is been finished. Let us do the loader first. Torch.utilities data loader. Note, this is in a different module than this. This is particularly about the video and image processing datasets, but the data itself is a generic notion. It's not limited to image and video data, so it is put in the root library of Torch. In case you are confused why there are two objects dealing with the data, one is the dataset and the other is the loader. The dataset are concerned with the data itself, where the data is being stored, if the data doesn't exist, where to download it, and training or test set, stuff like that. But data loader is concerned with how to bring the data specified by the dataset object to the data model. It is more operational about loading, arranging the resources, and make it efficient, stuff like that. Dataset object, and a very important parameter is called batch size. That means because the majority of modern datasets cannot fit into computer memory, so you need to decide how many samples to load at one time. Shuffle is a useful operation. As its namesake, it shuffles the data samples as shuffle a set of cards. That is because in some tasks, such as supervised tasks as what we are doing here, the data are organized in ordered manner. It might not be a good idea to provide your data model to let it send samples of one class after another. So if you shuffle the data before you provide it to the trainer or the model would say in each of its mini batch balance the mixed set of data sample, which is beneficial. Make it true, and you may guess the next parameter number of workers automatically do the parallelization of the data loading operation for you. Loading data dealing with operations with the disk, which is the slowest steps in the pipeline of data processing. By parallelizing this step, it can sufficiently enhance the efficiency of the algorithm. Before we go on, let's have a check those files. Okay, we now have a data object, and there are several processed and raw numbers data there. Now we have the training data loader ready, and we are able to get some data. But actually, this won't work. We'll see the issue and solution very shortly. To use a data loader, the format is very simple and very much according to our intuition. You do a for loop for x, that means the observation of the data attributes, and y, that means the labels of the data. Each of the x belongs to what kind of class in what data loader has to provide. That's it. So in the body of this for loop, you would be able to use x and y, a set of this number of data samples, which is 32 samples per batch in our case. And in each time, each iteration of this loop, the training loader will give you a randomly selected different set of data samples from data set. So the easy way to have a sanity check of how this works is to, after getting the first set of x and y, just break. So we just try to find the first set of data and the corresponding labels. Let's look what would happen. There would be an error, but don't be panic. Let's see what. Okay, this is a reason. If you Google this, you will find the corresponding author, but now I will tell you that is because in Torch it would expect some data contains objects in tensors. However, those image data are in the format of Python image library format. And but fortunately for us, Torch Vision also provides us a very convenient set tool of convert different format of image data. import this. If you only want one particular module, or you just want to give some shortcut for easy of typing of a particular submodule of a module, you do this from a library import called transforms. And let us do a transform. This is a very basic transform. We need to revise it later. Transform equals transforms dot compose yes. That means we can concatenate a link number of different transforms and let the data loader to perform one after another before it presents the data to you. But now we only do the in this case we only need one, that is to convert the PIL image to tensor. But this format is generic. We keep it in this way: transforms dot to tensor. Okay, and add another parameter here. Transform is transform. Oh, yes, we need to run this cell before we can use these transforms. Look, okay. Sorry. Go and go. Yes. Run and run. Not worked.